Welcome to another video lesson for Integrated Math 2. Today we're going to be looking at special triangles, specifically the 45, 45, 90 triangle. Let's get started. To begin with, let's look at our triangle here. We can see that we have a 90-degree angle by the given marking on our triangle, and we have another angle that is 45 degrees. The angle that we're missing is the one at the very top, which I'm going to go ahead and call y. And we can associate all three of our angles within this triangle by identifying that all angles add to be 180 degrees. So I have the two angles that I know, 90 degrees and 45, and the one angle that we're missing, and they all have to add to equal 180 degrees. If you combine the two angles that we know, we get 135. And then if I subtract 135 on both sides, we get that our angle is actually 45 degrees. So I can go ahead and rewrite this. Instead of being y, we can plug in a 45. Which means that I actually have two congruent angles. And since I have two congruent angles within my triangle, I can identify it as an isosceles triangle. Again, our reasoning is we have two congruent angles within our triangle. Now that we have all the angles of our triangle, we're going to go ahead and explore some of the properties that relate our sides. Knowing that our base angles for our triangle are congruent allow us to identify it as an isosceles triangle. And if our base angles are congruent, then the corresponding sides of our triangles are also going to have to be congruent. So for our side A, we can say that must equal 1. Now that we have two sides of our triangle, we can go ahead and use them to help us identify the missing hypotenuse. Knowing that I have a right triangle, and also knowing two of our sides, both of them equaling 1, I can go ahead and relate all three sides using the Pythagorean theorem. And that again is going to be a squared plus b squared is equal to c squared, where a and b are going to be your two legs, and c is going to be your hypotenuse. So for this specific triangle, a and b are going to represent our two legs, and our two legs are both equal to 1. So we have 1 squared plus 1 squared. And c, being our hypotenuse, is going to be b, which we don't know yet, but we're trying to solve for. All right, doing a little bit of simplifying, I get 1 plus 1 is equal to b squared, which means 2 is equal to b squared. And then if I finish solving for b by taking the square root of both sides, then we get the square root of 2 is equal to b. The 45, 45, 90 triangle gives us our second base triangle, and we have the corresponding ratios for our sides. The legs are both going to be 1, and the hypotenuse is going to be root 2. And we can use these ratios to help us solve for missing information in similar 45, 45, 90 triangles, just like we did with the 30, 60, 90 triangles when they had the ratios of 1 radical 3 and 2 for the sides of the triangle. Here we have two 45, 45, 90 triangles. And if we use our angle-angle similarity theorem, then we know that they must be similar. So we can use that idea to help us set up some ratios and solve for missing information. The first thing I want to point out is in my triangle here, we can see that both of my legs or my sides are equal to 1, which means that they are congruent. So in my other triangle, x is also going to be congruent to y. So I at least know that going into it. And then when I'm trying to set up my ratios, I can see that my hypotenuse is 8 for one triangle, and then for the other triangle, the hypotenuse is radical 2. So I have these relationships when I'm trying to set up my ratios to solve for missing information. We're going to go ahead and set up a ratio here to help us solve for x. So I'm going to start with x over 1, and that's going to equal 8 over root 2. If we do a little bit of simplifying, x divided by 1 is going to just be x. So we have x is equal to 8 over root 2. And from here, we want to rationalize our expression. And we're going to do that by multiplying our ratio, or 8 over root 2, by root 2 to get that radical out of our denominator. So if we do that, then we have 8 times root 2 over root 2 times root 2. And we get 8 root 2 over root 4, which is going to simplify to be 8 root 2 over 2. And if I simplify that one more time, then we get 4 root 2. And as I mentioned at the beginning, we see that we had two congruent sides for one triangle, which means that x and y are also going to be congruent. So we can say that x is equal to 4 root 2, and for the same reason, y is going to equal 4 root 2. All right, once again, we have another 45, 45, 90 triangle set, which means that we have similar triangles, and we can set up ratios to solve for our missing sides. Just to reiterate, we see that for our triangle, we have congruent sides here, which means that we have other sets of congruent sides. So right away, I can go ahead and identify y as equaling 3 radical 2. For my ratio, I'm going to make sure that I have root 2 and x paired up since they're corresponding sides. And I'm going to go ahead and use that to help me solve for x. All right, so we have x over root 2, and that's going to equal 3 root 2 over 1. I can simplify that right side, so I just have x over root 2 is equal to 3 root 2. And then I'm going to finish solving for x by multiplying both sides by root 2 here. So then we get x is equal to 3 times root 4, which will simplify to be 3 times 2. And finally, we get x is equal to 6. All right, for our next example here, I'm going to finish solving for all of my angles to verify that we do in fact have similar triangles here. Knowing that I have an angle of 30 and an angle of 90, if I subtract those from 180, then my missing angle is going to actually be 60. And again, using our angle-angle similarity theorem, we can show that we do have similar triangles. And this is just going back to make sure that we don't forget our 30, 60, 90 ratios. So I can go ahead and line up or match up sides. I can see that m is my hypotenuse, so that should correspond to 2 when I'm setting up my ratio to solve. And then my short side here is going to be 9 over 2, and that's going to correspond to 1. And then for my last side, n is going to correspond to root 3. So I want to make sure that I'm pairing up the correct sides when I'm setting up my ratios here. We're going to go ahead and solve for m first. So when I set up my ratios, I have m over 2, and that's going to equal 9 over 2 over 1. All right, I'm going to simplify that side real quick. So we have m over 2 is equal to 9 over 2. And if I multiply by 2 on both sides, then I solve for m, and I get m is equal to 9. All right, using ratios, we can also solve for n. So we have n over root 3, and that's going to equal 9 over 2 over 1. If I simplify that right side, then we again have n over root 3 is equal to 9 over 2. And then I can finish solving for n by multiplying by root 3 on both sides. And we get n is equal to 9 root 3 over 2 is our final answer. All right, your turn here. Go ahead and set up some ratios to help you solve for your missing variables v and u using the 30, 60, 90 triangles. All right, let's see how you did. So to solve for v, we have a ratio of v over root 3 is going to equal to 10 over 1. 10 over 1 will simplify to be just 10. So we have v over root 3 is equal to 10. And then from there, I multiplied both sides by root 3 to get it to cross off on one side. And for our final answer, we got v is equal to 10 root 3. Using ratios again, we can solve for u. So I start off with u over 2, and that's going to equal to 10 over 1 using, again, our corresponding sides here. 10 over 1 simplifies to be just 10, and then from there I multiply both sides by 2 to get it to cross off on one side, and we can see for our final answer u is equal to 20. All right, that does it for our notes for the 45, 45, 90 triangle. Go ahead and get started on the homework, and good luck.